Greetings. This is a project made by Shruti, Goutham, Gauri, and Ahalya. So for our project, we have selected text classification as our workflow, and we have extracted data from Kaggle, wherein the data is basically about diseases and their symptoms. So our idea here is to train the model in order to identify the diseases just based upon the symptoms. First here in the reading textual data section, we first upload um our data file here, which consists of two columns, basically disease and symptoms, along with the row ID. Next, we have the document creation meta node, wherein we filter out empty rows and we also convert the strings to document. And at the same time, we filter out all the other columns except for the document column. In our case, it is only the disease and the symptoms column. Moving on, for enrichment, we are just trying to uh, tag the part of speech. Here, we use the POS tagger, and if we want to view the document, this is how the part of speech will be tagged for each document. Moving on to pre-processing, here we try to filter out all the unnecessary data and clean the document, clean each document. And for that purpose, we will be filtering out numbers. We can also use the punctuation erasure node. We also have the stop word filter, but we don't have a separate table specifying what word we do not want. Then we have case converter, snowball stemmer, and tag filter. And in the end, we will be left with all the words that we require, and the words that we do not want are basically filtered out at this point. Moving on to the transformation section, this is also a meta node. Um, Here we try to create a bag of words. We try to extract words from each document, and we also calculate how many documents have the same term through with the help of the term frequency node. And then we also convert each word into a vector. The presence of a word would be indicated by 1 and the absence will be indicated by a 0 per document. So when we look at the table view, after the term frequency and also converting it into a big vector, we will see that each document will have certain words. These words are basically the symptoms for that particular disease, and one will be the presence of that symptom, and 0 will be the absence of that particular symptom. So once we are done with transformation, we go to color manager, wherein we try to assign different colors to different diseases so that uh, it's easier for us to understand rather than reading out every disease. And for the column filter, here is where we try to optimize the model. Instead of just excluding the document, we have tried to exclude all the other words and symptoms that have similar spellings to the diseases. For example, tuberculosis as a symptom will directly give the result as tuberculosis as a disease. Hence, so that that bias of the word being similar doesn't happen during the decision tree learner node, we have filtered these words out before we go for the decision tree learner. Finally, coming to the solution, here we partition our data. We have done a 70-30 partition, wherein 70% of the data will go for training and 30% will go for the testing purpose. We have selected stratified sampling, and we have also ticked off the your random seed so that it is the the model picks up similar sets of data every single time. Then we apply the decision tree learner and the prediction. So this is how it looks. Initially, the model has selected acne to start with, and blood in sputum. I think that is something that is a word that has been uh, cleaned. So based on that, if we keep going, so this particular word only this particular symptom only occurs in tuberculosis, and that is the reason why the model is 100% sure that it is definitely tuberculosis in this case. Similarly, for the next symptom, which is swollen extremity, again, it only occurs in hypothyroidism, and that is why the model is showing that as a 100% uh, sure diagnosed disease. Similarly, when we keep filtering it down, we can see that the model recognizes certain words that are specific to certain diseases, and it will give and throw out the disease as 100% with 100% accuracy. However, when we look at the scorer here, most of the diseases are recognized positively, successfully. The true positives are high for most of the diseases, except for certain diseases. Like, yeah, if you look at urinary tract infection, here the model has identified it as allergy three times, 3% of the time. So that are those are some of the small fallacies in the model. And if we look at the ROC curve for urinary tract, we can actually identify that the curve is not touching the top left corner. So if we select urinary tract infection and we select the P category of urinary tract, yeah, we can see that there is a small gap here. That is because the three times that the model has falsely identified urinary tract infection as allergy. Similarly, you can see that although most of the diseases have been identified correctly, there are still some diseases. One second. Yeah, there are some diseases which were identified falsely by the machine, by the model, sorry. Where is it? Yeah, four times, three times, two times for certain diseases. And because of which only the true positives would go down to 32, 33, 34 instead of 36. So yeah, that is our model. And if we get more data of diseases and their symptoms, which one of the constraints of this model is that the symptoms need to be described in the using the same words as the words that has gone into training the data, training the model. So instead of pain, if pain as a symptom, if it is described using some other word instead of pain, then the model won't will consider it as a new symptom and not a symptom that has been previously identified for the disease. So one of the constraint for this particular model is that whatever additional data is used to find out the diseases, the data needs to have the same set of words to describe the symptoms. So this model is fairly accurate for most of the diseases, and our conclusion is that with the similar set of data, we can also identify diseases given that the symptoms are have the same set of words to describe them. So that is all for our project. Thank you so much.